Okay, section 3.1, part 1. So we are starting on the physics unit. This is the last unit that we are going to have time to tackle this course. So the main things we're going to be looking at are the law of conservation of energy, potential and kinetic energy, and then we're also going to get into a bit the local and global impacts of energy transformations from technology. That is one area where we're going to have to cut a little bit of stuff, I think, though, in order to get it to fit in the time frame that we have to work with. Okay, so if you weren't able to find this information earlier, these are kind of our key concepts. So energy produces change in a system. There's different forms of energy. Energy can be either transferred or transformed. We'll go more into the differences between that later. And then physical quantities contribute to different forms of energy. Okay. So when you did your definitions, your key terms for the section, I'm going to hope that you maybe would have come across some of the different types of energy. So down here you've got a ton of different forms of energy that are sort of being shown. So just take a few minutes and look at kind of each of the pictures, and if you don't want to know what one of the pictures shows, that's okay, just skip it. But yeah, different types of energy that are maybe trying to be shown by these pictures here. In physics, energy is defined as the ability to do work, which means like you can actually do something with that energy. So scientists have investigated energy and have discovered several properties of energy. So these are kind of the key things for us to focus on. So energy can cause change in a system. So an example of this would be like heat energy changing snow to rain. Okay, so we actually see a result because of that addition of heat. There's different forms of energy, and those different forms of energy have different characteristics. So light energy is different from sound energy. The official name for light energy is radiant energy, because that includes the things that are in our non-visible spectrum from light, if you think back to Science 8. These forms of energy can either be transferred or transformed. So, for example, chemical potential energy in a battery can be transformed to light in a flashlight. So you can go from one form of energy to another. Nothing is like isolated or locked into its current form. And then different physical quantities contribute to different forms of energy. So the mass, speed, and ball will influence how far you can throw it. So looking at mass and speed being those sort of physical properties will then have an impact on how far you actually can throw it, which is based off of the amount of kinetic energy that it gets. So if you are a scientist trying to study a newly discovered form of energy, what are some of the challenges you need to overcome? How would you observe energy? How would you make observations? And what kinds of tests would you do? So there's kind of no real wrong answer here. We do have some examples of some of the different things that have been done, trying to investigate new forms of energy as they have been discovered. So think about what are problems with energy. Can you see energy? Is it easy to measure? Even if it's like heat energy, you can feel it, but how do you quantify that? So how are you going to actually observe things? How are you going to make your observations? What kind of tests are you going to do? How are you going to be able to record that information, given what we know about energy in general? Energy systems play an important role here. So a system is defined as anything that is under observation. So it's just simply like what we're looking at. Looking being could be smelling, hearing, all those things as well. So the bungee cord, the person using the bungee cord would be considered a system. Okay, so in this picture, because that's what we're observing. A system is something that we define. Okay, and different people are going to have different perceptions about what should be included in a system. So would you include the bridge in describing a system for a bungee jumper? You might say yes, you might say no, and there is no wrong answer for that. Both are totally valid. You just need to define what you're including in your system when you are then describing it and doing any kind of relevant calculations. Okay, so other types of systems, other examples of systems. So this is other than a bungee jumper and its bungee cord. So literally anything that you want to think about that is using energy in some way, shape, or form, and then once again sort of defining it under the parameters that you see fit. It is pretty hard to go wrong with this. Okay, so I mean, we've got an example of a thermos here. Okay, so that the heating of the food for the thermos, that would be considered our system, okay, so the food within it. You could go further back and you could say, okay, the microwave that heated up the food that you then put in the thermos or whatever. Okay, anything that's in the universe that we're not considering to be part of our system would then be considered to be the surroundings. So in the case of the bungee jumper, the surroundings would be the sky, trees, other people, nearby cars. Depends on where you're bungee jumping. If it's going off a bridge, there's either, say, a road underneath or there's a river underneath or whatever. So anything that is literally in the universe that is not included in your system would be considered to be the surroundings. So you could stretch your surroundings as far back as you wanted when you were describing them. Okay, so if you thought of any other systems, then you'd want to start thinking about the surroundings. So looking at that thermos, we could then talk about the surroundings being the counter, and there was the stove, and there was anything else that you wanted to possibly include from that picture and beyond. Okay, so our equation that we use to sort of talk about this is the idea that the universe is equal to the system plus surroundings, and that's literally everything. So you've got your system, you've got your surroundings, and together those things make up your universe. You can isolate that down as far as you want, once again, kind of depending on how vague you want to be. So our system, looking at water molecules specifically, could be either water or ice, and the surroundings would be everything else. So the cup that's being held in, the air that's around it, the table that it's sitting on, the person walking by, you the observer, on and on and on and on and on.